So till now, what we discussed, we discussed the Lambda core functions. So there are four Lambda core functions. One is predicate. So predicate takes an argument but return Boolean. Second is the consumer. Consumer can take argument but do not return anything. Supplier. Supplier do not take any argument, return anything, any kind of data type. And the fourth one is the function. Function can take any argument and return anything. But in the java.util.function package, there are 43 functional interfaces, and till now we discussed only 4. Now, what are the rest 39 functional interfaces? For that, we need to first understand the autoboxing and the unboxing of the Java. So, autoboxing is the where Java is converting the primitive type int, long, double, boolean to wrapper classes like integer, long, double, or boolean. And the unboxing is the converting the wrapper classes to the primitive data type, that is just exactly opposite of autoboxing. So this is Java compiler is automatically doing for us. So let's understand with this example. So I have created two function. One is simple predicate, second is the primitive predicate. So simple predicate, I have created predicate of the type of integer. So this predicate is taking integer as a input and return boolean as a output. And here I'm checking like x first, taking x as an input, and checking x should be greater than 10, then it will return true. So I am calling this predicate using the test method 100 times, and I am calculating the execution time using system.nano time. I am calculating the execution time of this function. Same thing I am doing for the primitive predicate. Now what is primitive predicate? So I'm specifying here int predicate. So it is type of predicate. So the difference is this int predicate deal only with the int primitive type, not the integer. So this predicate deals with the integer wrapper classes object. Here this int predicate will deal with the int primitive type. So here same implementation I have applied. X should be greater than 10, and then this I'm calling this function 100 time, and again I'm calculating the execution time of this primitive predicate. So here I'm calling both this function and I'm calling both the function 100 time. So let's see the output. So we can see the primitive predicate is taking less time as compared to the simple predicate. Why? The reason is primitive predicate is dealing with the int. So there is no autoboxing or the unboxing is happening here. But in the simple predicate, autoboxing and the unboxing is happening. So because when we are calling this greater than 10 and to test, we are passing int, but this predicate is taking the integer. So first time autoboxing is happening here, converting int to the wrapper class, that is integer. Next, when we are doing the comparison, then the unboxing is happening. So x converted from integer to int, then the comparison is happening. So Java is doing two time this. First, autoboxing is happening when we are passing the argument. Second, when we are evaluating the expression, then the unboxing is happening. So that's why this simple predicate is taking more time as compared to the primitive predicate. In the primitive predicate, everything is in the int world. So here I pass int, this primitive int predicate takes int, and the comparison is happening in the int. That's why there is no autoboxing or unboxing happening or not required. So that's why primitive predicate executing faster as compared to the simple predicate. So in some cases we need more performance, and this type of minor performance is required. So we can use these type of primitive predicates or primitive functional interfaces. Same thing is happening for the primitive consumer. So here again I have created two consumer. One is the normal consumer and second is the primitive consumer. In the normal consumer, we already have seen like consumer, and I'm passing integer as a wrapper class, and I'm doing nothing here. Implementation is empty. I'm calling this pin code consumer dot accept 100 time, and I'm calculating the execution time in the nanosecond. Second is the primitive consumer. So I have created the int consumer, and here implementation is again empty, and I'm calling this int consumer 100 time and calculating the execution time. So same like a primitive predicate. So I'm calling this both the function 100 times. So let's run this function. Yeah, so here we can see the primitive predicate is taking less, primitive consumer taking lesser time as compared to the normal consumer. The reason is same, autoboxing or the unboxing. So in the normal consumer, first we are passing the int here, and but consumer is accepting the integer. So here autoboxing is happening, but here no autoboxing is happening. This int consumer is dealing with the int only. Now the third is the primitive supplier. So again, I have created two functions, simple supplier or the primitive supplier. In the simple supplier, I am iterating the loop, and I have created supplier of type integer, and I am returning the int here, and here I am calling the supplier dot get and assigning the value to the int. So here I am calculating the execution time of simple supplier. Second is the primitive supplier. So in the primitive supplier, I have created supplier of int supplier, and same way I am calling the int supplier dot get as a int function, and I am calculating the execution time of primitive supplier here. So both the functions I am calling 100 time. Let's run this program and see the execution time. Here we can see the primitive supplier is taking lesser time as compared to the simple supplier. The reason is same again, autoboxing or unboxing. So in the simple supplier, so here we are returning the int here. This is a int, and this supplier is type of integer. So first autoboxing is happening here, converting it into integer. Then I am calling get function, and I'm assigning this get value in the int. So here unboxing is happening here, but again int supplier is dealing with the, or int supplier is using the int only, int primitive type. So whatever we are returning same int type, this int supplier is returning, and we are again same passing to this val function. So